We're going to continue our topic of solving quadratic equations by looking at some application problems. So in example 1, we have the length of a room is 2 meters less than 3 times the width. The area of the room is 96 square meters. Find the width of the room. The first thing that you always want to do on one of these type of problems is to make a sketch of a rectangle. We have a length and we have a width. The problem is going to tell you something about either the length or the width. In this case, it says the length is 2 meters less than 3 times the width. So the length is 3 times the width, but 2 meters less than that, so minus 2. It also tells us that the area is 96 square meters. So we're going to start with the area formula. Area equals length times width. And now we're just going to fill in the parts that we know. So what do we know about A? We know that it's 96. What do we know about L? We know it's 3W minus 2. What do we know about W? Nothing. So since it's going to be multiplied, I could write it on this side, but I'm going to put it over here so it looks more familiar to you as a distributive property. Now I'm going to distribute. So 96 equals W times 3W is 3W squared minus 2W. And because I have a quadratic equation, I know that because of that squared term, I know that I have to get my equation equal to 0 in order to use the zero factor property. So I'm going to move over here and write what I have left. I have 3W squared minus 2W minus 96 equals 0. So using our acronym again, I have zero factor property. I just got my equation equal to 0. I now need to factor. Well, unfortunately, I can't factor out a 3 or anything else. So I'm going to have to multiply and use this long method. This will be a good review. So 3 times negative 96 is negative 288. I'm going to just make sure everybody has time to do that on your calculator. Now we're looking for factors of negative 288 that combine to make negative 2. Now I don't know about you, but I don't know those off the top of my head. I do know that I need a positive and a negative to get a negative 288. And I know the larger number is going to have to be negative to have a leftover 2 when I combine them. So I don't know what they are. I'm just going to start out and make our list. 288 times 1. And then I'm going to scoot this over. We're going to do what we did in the last topic, where I divide this by 2, multiply by 2. Divide by 2, multiply by 2. Divide by 2, multiply by 2. Divide by 2, multiply by 2, and there is a way that I can get a 2. So I know that the larger one is negative, so this is positive. Now we're going to bring down, I'm going to break down the middle term into negative 18W plus 16W. That's what I just found over here. Bring down my last. Now I have 4 terms, so I'm going to group. There's no problem because I have a plus in between. I'm going to factor out the GCF of this first binomial, which is 3W. I'm left with W minus 6. Bring down my plus. I'm going to factor out the GCF here, which is 16, and I'm left with W minus 6. So my two factors are W minus 6 and 3W plus 16 equals 0. So I just did that part. I factored. Now I apply the property by setting each factor equal to 0. So either W minus 6 equals 0 or 3w plus 16 equals 0. Here I add a 6 and I get w equals 6. Here I subtract a 16 and I basically can stop. The reason is I'm going to end up with the negative width here. And I can't have a negative width of my rectangle. So I can discard this answer. Even though it solves the equation, it doesn't make sense in the context of this problem. So I know that the width is 6 meters. And to find the length, I'm going to use right what I wrote on my diagram. 3 times the width minus 2, or the length, is 18 minus 2 is 16 meters. So I have my width and my length. All right, let's look at a different kind of problem in example 2, another solving a quadratic equation using the zero factor property. It says if a small rocket is launched vertically upward, so here's ground level, this rocket is launched vertically upward, with an initial velocity of 128 feet per second, then its height in feet after t seconds is a function defined by the height is equal to negative 16t squared plus 128t. Now it says after how many seconds will the rocket be 220 feet? In other words, we want to know when will h of t equal 220. So it's going to hit 220 feet sometime on its way up, maybe right here, but then when it turns around and comes back down, which it will, it's going to hit it again. So I take this equation, h of t stands for height, I take that all out and replace it with 220. It's not 220 times t, it's just 220. Remember, this is just an announcement that, hey, we're solving for height. So we take that out and put 220. Negative 16t squared plus 128t. Using the zero factor property, I know that I need to get this equation equal to 0. Now I don't like this negative in front of my squared term, so I'm going to add a 16t to both sides, and I'm going to subtract a 128t from both sides. That will give me my 0 on the right, and here I'm going to have 16t squared minus 128t plus 220 equals 0. And I certainly hope there is a GCF, because I don't want to multiply 16 times 220 and try to find those factors. And there is. You can check in your calculator. 16 won't go into 220, but 4 goes into all of them. So I'm first going to factor out of 4 and get 4t squared minus 32t plus 55. I can divide both sides of my equation by 4 to get rid of that 4, and I have 4t squared minus 32t plus 55 equals 0. Now we still have quite a factoring task in front of us, because this is a long process, and I'm going to have to multiply 4 times 55 and get positive 220. And I need factors that add up to negative 32. Not knowing what they are, we're going to list all of them. So 220 times 1, divide by 2, multiply by 2. Divide by 2, multiply by 2. Now I can't divide by 2 or 3 or 4, but I can divide by 5, multiply by 5. That doesn't give me 32, it gives me 31. Go back to the big one, divide by 2, multiply by 2, and that is how I can get my 32. Now let's figure out the signs. To get a positive, I need a positive times a positive, or a negative times a negative. To get a negative 32, I need 2 negatives. So we are going to break down the 32 into these two pieces. So that's going to be negative 10t minus 22t, and then bring down the last group. You see that negative in between? That means you need to make a correction on that last term. Let's factor out the GCF, and I don't want to run out of space down here. I'll write one more line and then move up where you can see. So let's factor out a 2t, and I'm left with 2t minus 5 on my first binomial. Bring down that minus sign. Here I can factor out an 11. I'm left with 2t minus 5 equals 0. So my two factors are 2t minus 5 and 2t minus 11 equals 0. So we have gotten it equal to 0 and factored. We now have to apply the property. So either 2t minus 5 equals 0 or 2t minus 11 equals 0. I solve both of those. I'm still running out of room. I get t equals 5 halves, which is 2 1/2 seconds. Or here I add an 11 and divide by 2, and I get t equals 11 halves, which is 5 1/2 seconds. So 2 1/2 seconds would be on the way up. It hits a height of 220, and then it continues up, and then on the way down, it hits it at 5 1/2 seconds. So here are your two answers. That was quite an involved problem. Continuing on, let's look at the next page, which has to do with literal equations. This is how I always like to finish a section. Literal equations. It says recall. Literal equations are equations with multiple variables in which you are asked to solve for a specified. So we looked at ones like this. 2L plus 2W, and we were supposed to solve for W. And what we did, this came up before, we would get everything away from that 2W and then divide. Now that I have my variable in the term isolated, divide by its coefficient, and we would get W equals P minus 2L over 2. And those weren't too difficult because whatever letter variable we were looking for, there was only one of them. Well, that's a little different in this section of factoring, because the variable that we're going to be looking for, there's going to be more than one of them. So let's use this formula in example 3. A equals 2HW plus 2LW plus 2LH. And we want to solve that for L. So when I go into my equation and I look for L, I see one here, but I also see one there. So just like we did in this example, we need to get the terms that contain our specified variable, the two orange variables. We need to get those on one side and everything else on the other. So I am going to subtract a 2HW. That's going to give me A minus 2HW equals 2LW plus 2LH. And now we still have a problem because the variable that I'm looking for right there in orange, there's two of them. And I need to go from having two down to just having one so that I can then divide by its coefficient. So how do we do that? Well, the way that you do that is you factor that variable out of the right-hand side. So factoring out an L as the GCF. And by the way, I realize you could also factor out a 2, but we don't want to do that because we want the L to be by itself. We would be left with 2W plus 2H equals A minus 2HW. So I went from having two of those L's to just having the one, and we did that by factoring. Now I can do the same thing I did up here, which is divide by the coefficient. So I divide by everything that is not L. And I do that on the other side, same way. And I end up with L equals A minus 2HW over 2W plus 2H. And no, you can't cross cancel 2's. So let's summarize. What did we do? 1, isolate the terms. In this case, there was more than one. There were 2 containing the specified variable. I'm going to use an abbreviation there. 2, get everything else on the other side. 3, and this is the key, factor out the specified variable. That is the key to the whole thing, going from 2 of the letters down to 1 by factoring it out. And 4, divide by the coefficient of the specified variable.